WB Engineering established in 2007. We are in the vertical markets of medical devices, consumer products, and aerospace. We're also a partner with 3D Systems. We sell 3D Systems and support the 3D Systems printers in the state of Florida. We're also Autodesk partners. We sell and support the software for the state of Florida as well as training. So firsthand, we at WB Engineering, we've seen how 3D printing has affected our bottom line. We've been fortunate enough to have access to this technology relatively early on, though this technology has been around for a while. We have seen it affect our bottom line. Keeping the same size team, we've been able to compress our design cycles, take on more projects, and also see our profit margins increase. Because of having this technology in-house, we've been able to have clientele in the Fortune 100 status, and that's a big sense of pride coming from a small companies like ours. So I'm going to hand it over to Brad. He's going to give you a little bit of background on 3D Systems.
Good afternoon, everybody. My name is Brad Stern. I work for 3D Systems. I'm the regional channel manager over the Southeast. And thank you, Werner, for hosting today's presentation. I want to tell everybody a little bit about 3D Systems as a company. It's a large misnomer in society. A lot of people think that 3D printing is a fairly new technology, but in reality, 3D printing started about 30 years ago when 3D Systems Chief Technology Officer, Chuck Hull, actually invented the very first SLA, or stereolithography printer, back in the mid-1980s. 3D Systems was then the first to commercialize the 3D printing with SLA. And then throughout the course of the last 30 years, we continue to innovate and introduce new methods and techniques of 3D printing from not only SLA, but also selective laser sintering, or SLS, and also CJP, or color jet printing. We've also got DMP and direct metal printing products and technologies. Werner, what am I leaving out? We've got micro SLA. We've got plastic jet printing, which is a plastic jet extrusion-based product. And I feel like I'm leaving one more.
I might have missed it, but I think you about got them all. If we missed any, we'll make sure to follow up. Also, this is the first of a full web series. We will be going over each one of those technologies specifically in the coming up webinars.
Yes.
Okay.
And so throughout those 7 different technologies, we've got about 30 different products and over 120 different materials that you can print in, from metals to ceramics to different powders, plastics, and so forth. Our headquarters are also in Rock Hill, South Carolina, where all of our products are manufactured. And we've got a network of over 20 offices worldwide and service technicians and partners in almost each state and country to make sure that our products are serviced up to our customers' expectations.
Okay, thanks, Brad. Appreciate it. So we're going to look into right now where 3D printing is currently being used. So we have across the board, 3D printing has been used in a lot of different industries, right? So industrial products, one of the biggest markets, consumer products, automotive, medical, aerospace, academics, government, and then we have a small percentage for others and architecture, right? So 3D printing is starting to become a standard tool for companies, specifically in the industrial products and consumer product realm. It's also starting to become a standardized tool in automotive, medical, and aerospace. So 3D printing is now getting to the point where if you're not currently using 3D printing and you're in one of these key markets, you could start falling behind the curve. We have customers in all different industries, and we have noticed that the market leaders do actively employ 3D printing as a part of their regular day-to-day activity. And we've also noticed as a partner of 3D Systems a big increase in interest in terms of budgeting and actually implementing 3D printing over the last 3 years or so. Okay, so let's go into some specific examples of 3D printing, right? So one of the biggest areas that we've seen huge boom in 3D printing is aerospace and also engineering optimization. Why? Well, because currently 3D printing is something that you can use and you can create really complex, optimized geometry without adding cost to your design. This is a good example. It's a company called Firstum Inc. They actually did a direct metal printed part that was able to cut 70% of the weight of the original product while maintaining the same mechanical strength, right? So in aerospace, needless to say, this is a very, very important fact to be able to get a hold of a part that is just as functional and reduce your weight by 70%. So I was actually at a client's place a few weeks ago. This is exactly what they were looking at 3D printing for. They designed something that has to carry a certain payload. The payload actually is something that they lease or sell to their customers, so therefore if their device is a quarter of the weight, that means they have that extra weight to sell to the customer. So that's one of the big markets there. The other one is medical devices, right? So this is an example of somebody at Microdent, the founder of Microdent. He says even several years ago, metal 3D printing was good in terms of productivity, quality, and economics. He's just pointing towards the future, saying, you know, this is something that is going to be a must in the future in terms of medical devices. We have a couple other medical device examples here. One using our Projet 3500, which is now the Projet 3600. They were able to produce very small, intricate geometries with the tight tolerances that they require, right? So if you have seen 3D printing before, you might have seen entry-level, consumer-level 3D printing. Once you start getting into the professional level printing, you can actually start to accomplish very, very high tight tolerances, and therefore you can start to work with geometries that used to be extremely difficult to produce, particularly in the prototyping realm. Furthermore, there's another company here, Gyrus ACMI. They were able to cut their lead time in less than half using 3D printing for a plasma knife that they developed. In fashion and jewelry, this is another application that is huge for 3D printing. Today, it's in the realm of possibility, per this one of our customers here, that they can actually receive a print or a file of a piece of jewelry one day. They can then move forward and print that the same day and be able to ship or cast the next day and then ship and deliver within 72 hours. So this is the kind of stuff that was not possible beforehand. The other beauty of this is that you can actually submit multiple parts to the same print. So overnight you can have a full assembly of complex jewelry being printed and then cast. Now this doesn't just limit to jewelry. You can do this with other small complex parts that you want to print and then cast, to medium-sized parts as well. So our printers do have cast-friendly material, and if you're in the casting business, you can actually use this for complex metal devices. Another point we wanted to look at is functional prototypes, right? So this is one of the more obvious applications that 3D printing has, which is you are able to produce functional prototypes, iterate and optimize very, very quickly, right? So in this example, you're able to explore different types of geometries prior to going to production without having to invest significant amount of money and time into molds, which are out of expensive materials. Internally, we have a lot of experience with this kind of application. That's what we do day in, day out. The best part about this is that we're able to make mistakes in-house and then reiterate, optimize, and then print again in the time that an average company is able to find out their first error, right? So we're able to go through many, many iterations over and over and over again from one day to the next in the same amount of time that somebody might be able to get one prototype out. So an example here is we'll have a design meeting in the morning. We'll go over a couple different options that our engineers have presented to us. that afternoon we will submit them to the printer. The next morning we can all meet with our actual physical prototypes in our hand, and then therefore have a very educated debate over which design is actually optimal, which one has the best features, which one will best meet our expectations, etc. So this kind of stuff is near impossible to do without the ability of having 3D printing in-house. Okay, next up is production tools, right? So we're getting into the realm where 3D printing, or we are in the realm where 3D printing can actually produce production quality parts, right? This is an example of one of our SLS printers. This is a company that does pistons. The pistons actually cut potatoes into certain shapes. So for having 3D printing, they would actually have to CNC machine these parts, and the lead time was about 25 days. So now the 3D printer is actually able to do this faster. Not to mention, it's also able to free up the CNC machines for parts that need to be CNC machined out of a specific material, let's say. So, you know, 3D printing isn't just brittle plastic parts. We do also have 3D printers that produce production quality parts, and we can actually output that to real functional applications. The other example we wanted to show was 3D printing is actually getting to the point, or got to the point, where it can be implemented in mass production as well. So a lot of times people think of 3D printing as the end part, right? We also like to point out that 3D printing can be part of the process, not necessarily the end part itself. We do get a lot of kickback from a lot of customers saying, oh, well, you know, my product is made out of this specific plastic, or my product is made out of this specific metal, etc. Well, now you can think of 3D printing as part of your portfolio of tools to get you to the end point, right? An intermediary, let's call it. So in this example, this company actually produces injection molded parts, and they're able to get the same tolerances as they do off of a steel mold, and they're able to produce the part in the exact material that they require for the application. Therefore, you no longer have to worry about the small nuances between our polypropylene-like or ABS-like material. You can actually inject it with the exact polypropylene or the exact ABS that you would like and get your part. You can also, these molds do last for several cycles. There's an obvious difference between the fact that you're not using a metal mold. These do have their limitations, but you can get several cycles off of a 3D printed plastic mold, and therefore it'll help you better understand your end product prior to having to cut steel. The other one is jig and fixtures, right? So this is another point that I like to use is a lot of the times when you're producing parts to produce parts, if that makes any sense. Let me, I guess, explain it a little bit. To CNC and machine certain parts, you do need jigs and fixtures, right? So if you're going to make said end product, you're probably going to need some jigs and fixtures to get to that end product. With 3D printing, you're able to 3D print those jigs and fixtures to specifically get to your CNC part faster. Furthermore, in this scenario, they needed to come up with custom clamps for picking up 300 different models, and they said, you know, prior to using 3D printing, they would have to use milling, which takes a very, very long time. So you can use 3D printing, again, as an intermediary to the end product. In this scenario, jigs and fixtures. In the previous one, you can actually use it to make the mold. This is a good example of consumer products. This is a company called American Precision Prototyping. They were tasked with actually creating something for FIFA, and they had to do it in a very, very tight timeline. With that tight timeline, they had to redesign, prototype, get the prototype approved, cast, decorate, and ship 150 urethane bottles for Powerade. So they were able to do this with the entire job within 30 days using CAD and then SLA 3D printing. So they were able to print at scale, print full size, make a urethane cast, decorate, and then have it in the World Cup. This is just an example of another company, Cisco. They use 3D printing for plastic electrical enclosures. They're able to use this type of technology to get prototypes quickly, refine them quickly, and then deliver, in his modest words, their elite designs, right? So this is something that rings a bell or hits home for us. We do this day in and day out, and this is what actually gives us the edge to be able to compete with other product development companies. It's the fact that we have access to this kind of technology in-house, and we're able to refine our design, present it to our customers, have their feedback, and then be able to apply that directly to the design thereafter. Scale models. This is another one that we've seen a lot of progress with. This is an example off of one of our ProJet 3500s. So in this scenario, they're able to make very impressive scale models of their designs in order to replicate certain types of geometries which are very impossible or very laborious to do without 3D printing. Architectural scale models. So this is one that is a pretty obvious application and is something that is starting to grow significantly. We all know back in 2008 the economy got pretty rough, so architectural applications did start to linger quite a bit, but currently, as things are starting to get back into place, or got back into place, I guess depending on what industry you're in, you do start to notice that architecture is starting to pick up again, and they are starting to leverage 3D printing to make very, very detailed scale models while reducing costs significantly and getting very, very fast turnaround times. This is another example. Again, this is very close to us as well. It's a pre-production validation, right? So this company actually used rapid prototyping. In their scenario, they were able to compress their design cycle by 3 to 6 months. Also, they were able to make sure that their product was perfect before they actually went to prototyping and cutting hard tools. So I'll let Brad take over this slide so he can help explain some of the core benefits of 3D printing.
Thanks, Werner. So many of these, some of you may be familiar with, but overall 3D printing is opening up a world of possibilities, not just from the examples that Werner had alluded to earlier, but also it's helping companies to iterate quicker and more efficiently right in their office with 3D printers that are more and more office friendly and affordable with some of the products that WM Engineering and sells and 3D Systems manufactures. So faster time to market. So we're helping to compress design cycles, making companies from multiple industries more competitive in their markets. This includes, this is enabled by shortened design cycles, also the flexibility and convenience to prototype faster and more efficiently in your office. Once an engineer has an idea or multiple ideas, 3D printing is enabling them to bring these ideas to life quickly and affordably, and able to communicate some of these prototypes to other engineers so that they can then take these designs or designs that seem more feasible than others to market quicker. It's also helping companies to make decisions quicker, so that if they if they want to change up maybe a certain facet or a shape of a specific design, they can do this quicker with 3D printing. But overall, I think the underlying theme is that 3D printing allows for more ideas and more breakthroughs, and the ability to make better quality products, higher quality products as well. So, and we also talked earlier about jigs and fixtures, and also improving manufacturing processes as well.
Thanks, Brad. Appreciate it. So I'm going to take this opportunity to go ahead and see if we can learn a little bit about our audience here. So what I did was I wanted to see if maybe we can find out if anybody has actually used 3D printing. And if so, have you used it in-house? Have you outsourced it? Do you use both? Or do you not use 3D printing at all? All right, so it looks like everybody has answered. We're going to now move into the other one. So it looks like we have a lot of people here that actually use 3D printing in-house. That's great. I'm glad that there are people taking advantage of this currently. So on this next one, we're going to see if anybody's looking into 3D printing. I understand a lot of you already have 3D printers in-house. You know, I don't know if this is something that you're looking to expand upon. And also for those of you that are just researching, we'd love to help you better understand the technology. We are going to be following up this webinar with more specific webinars further on, right? So the next one will be 3D Printing 101, where we're going to be going over the technologies in general, and then we're going to follow up with 3D printing specific to the technologies and the applications for each one of those technologies. It looks like we have all of our votes in here. Whoops, sorry. So now we're just curious a little bit of what people are going to be using 3D printing for. We did present a couple different case studies in different industries. It's always nice to see what people are using 3D printing for. Remember, we could use 3D printing for a wide range of applications. Day to day, we're actually noticing that our customers are teaching us more about all these intricate ways of being able to use 3D printing beyond just prototyping. One of the more interesting ones that I've seen recently are in the casting industry, and then also sales and marketing is actually taking advantage of this as well. So it looks like everybody voted in there. Oh, it's nice we have some end-use products, which is pretty nice. All right, last. So based on your application, there are certain printers that are able to accomplish different types of tasks, right? So we want to make sure that we align the printers that we recommend with a budget that you might have already in mind. So we want to make sure that we give you realistic expectations as to what a 3D printer can do for you when you actually when you're in a certain price point. All right, so it looks like almost everybody has answered. Just a couple more people. I'll let them. Okay, looks like everybody's in. All right, well, thank you guys very much. So what we're going to do here now is I'm just going to finish closing this out. So yeah, 3D printing is all around us, right? So this is a small section sample set of customers that 3D Systems has that are using 3D printing currently. It's a very impressive portfolio. It has grown. Good thing is that 3D printing has come down, or professional 3D printing has come down in price, so it's getting accessible to more and more small, medium-sized companies. We're a small company. We're very happy that we invested in this technology, and it's made all the difference. Just a peek into the future, wanted to see if anybody else liked this. We'd like to see if maybe you guys can join us for more in-depth 3D printing webinars, specifically 3D Printing 101. It's going to be an hour long. It's not going to be a short 30-minute one. We're going to be going over each one of the technologies very briefly, and then we're going to follow up with 5 more webinars where we're actually going a little bit more in depth into each one of the technologies. So if you're interested in learning specifically into one of the technologies, feel free to join us on one of those webinars. If you're still not sure what technology is going to work for you, I would recommend going to the 3D Printing 101 webinar. This will help you at least get to see at a high level what each one of these technologies can produce, and then hopefully we can continue educating you from there. So if anybody has any questions, feel free to put them in the chat, and we will go ahead and address them with everybody. If there's anything that you guys would like to send to us, you can please send all your questions to sales@WB3D when we're offline, and you can go to our website or give us a call at the office. So I'll give you guys a couple minutes, submit any questions you may have, and then Brad, I guess if you want to close out with anything, feel free.
So I just want to again thank everybody for joining us today. We had a great turnout, and please join us next week. As Werner mentioned, that we've got about an hour session, yes, next Monday, where we're going to cover each of the 7 different technologies of 3D printing, what their unique applications are, as well as the materials you can expect to receive as an output from each of these products in each technology portfolio. Also, for anybody that's interested in seeing some of our products live, Werner has a showroom in Miami, and he can send out details about where the showroom is, where you can see a couple of our products in action, one of which is a multi-jet printing product, another is a color jet printing product, and I believe you've got an SLA product as well, if I'm not mistaken. So definitely come check him out, and he's also got a variety of parts as well to display that can show you a variety of applications and some of the output you can expect, not just from the printers he's got on hand, but from some of the other products in our portfolio.
Okay, well, it looks like we'll be able to answer all the questions. If you have any questions once we get offline, feel free to send us an email. If not, well, thank you guys very much for your time. We hope to hear from all of you in the near future. We'll follow up with a quick thank you email, and again, thank you for taking time out of your day to listen to this webinar. Take care and have a good day.
Thanks, everyone.